This is Unit 5, Review 2, Questions 3 and 4. So question number 3 says, determine the dimensions of the largest rectangle that can be formed by the parabola y equals 12 minus x squared and the x-axis. All right, so the nicest thing to do is to go through and actually draw this out. When you do so, you have your parabola. It's an upside down parabola. Technically, we'd be going through a 12. We moved up 12. All right, so we have our red curve here is dictating that part, and then we have our x-axis. So the x-axis here would be this pink line, and we would find the biggest rectangle we can fit underneath there. All right, so that rectangle, since this parabola is just moved directly up, it's not shifted left or right, that means it is symmetrical about the y-axis here. So I can flip it directly over and it would match up perfectly. So what that means is when I'm trying to find out the biggest rectangle here, what I'm really trying to do is maximize the area of the rectangle. So since I want to maximize my area is going to be what I'm going to take the derivative of. So the area here is equal to x times by y. You see I have the x and the y on my graph. I don't need the x to be the entire bottom. Again, if I maximize the right side of this, it'll maximize the entire thing since it is symmetrical. All right, so when we go through and solve these, we always have one equation that we are going to take the derivative of. And when we do that, we only want one variable in there. So I need to replace either x or y. So I always have a helper equation. So what's my helper equation? Well, it's given to you in disguise, really, in the original problem. It says f of x or y is equal to 12 minus x squared. So again, that's really just y equals 12 minus x squared. That is my helper equation. I'm going to take that and plug it in here. So a is equal to x times by 12 minus x squared. I'm replacing my y. Distribute the x. A is equal to 12x minus x to the third. Take your derivative. A prime is equal to 12 minus 3x squared. Again, you're setting this equal to 0. 12 is equal to 3x squared. Divide by 3. X squared is equal to 4. Square root x is equal to 2. So if x is equal to 2, and since this is symmetric, that's 2. That means it's 2 to the left as well. So that my dimensions here are going to be 4. And this didn't have any units, so we're going to call it 4 pi. And then when I figure out what my y is, I take my x equals 2 and I plug it into my helper equation, which is the y equals 12 minus x squared. One note of caution, make sure you don't plug the 4 in. Plug in the x, which is 2. It's going to give you 12 minus 4, 2 squared, and that's going to give you 8. So it's 4 by 8 is the size of the largest rectangle that you can have underneath a curve. Number 4. So number 4 says a playbill is to contain 50 square centimeters of printed material. The printed material is the inside. You can see I have my outside rectangle. We've done these problems before, and the inside rectangle, the red. That's 50 square centimeters. That's the one that's going to be my helper equation. I've said over and over again, whichever one they give you is your helper equation. So in this, I'm going to have my x and my y. Again, you want your helper equation to be as simple as possible. The x and the y are going to be on the inside rectangle. So area here is equal to x times by y, and it tells you the area is 50. So it's 50 equals x times by y. That is my helper equation. I'm going to use that then to solve my second area, which is going to be this big one. So how do I find the area of the big one? Well, I need the two sides. So if we continue reading here, and you can see I already have it marked, it says there is a 4 centimeter margin at the top and the bottom, there they are, and 2 centimeter on the left and the right. All right, so what are the dimensions for the playbill that would use the least amount of paper? So we're trying to minimize the area here. We're trying to minimize the area, the amount of paper we have. Given that we have that 50 centimeters squared in the middle, the area, and those margins around it. So when I do this, again, if this distance from here to here is x along the bottom of the red rectangle, and this is 2 and that's 2, that means this is x plus 4 then. And likewise, if this is y from here to here along the right side of the red rectangle, I'm going to add 4 since this is bigger, this is going to be a y plus 8. So the area of the outside rectangle is just x plus 4 times by y plus 8. So again, when I solve here, I'm going to need to replace one of those variables. It doesn't matter which one you solve for. All right, I'll just solve this for y. So over here, I'm going to have 50 over x is equal to y. Take that, plug it in. So a is equal to x plus 4 times by 50 over x plus 8. I typically leave it as 50 over x just because when I FOIL now, it's easier to see that x times 50 over x is just 50. We're going to have plus 8x plus 200, and here I'll bring the x to the top, x to the negative 1, 4 times by the 50 over x, and then plus 32. All right, I can combine together my like terms. You don't have to do this. All right, but I'll do that for this one. So it's 82 plus 8x plus 200 x to the negative 1. And the reason why I say you don't need to do that is because the next step is to take the derivative. And the derivative of any constant is going to be 0. So they're just going to drop out whether they're added together or not. So 82 goes away. You have 8 minus 200 x to the negative second is equal to 0. Again, derivative is always equal to 0. Add the 200 to the right side, so you get 8 equals 200 over, and then bring that x to the negative 2 to the bottom. So it's over x squared. 8x squared is equal to 200. So once you have the 8x squared equal to 200, you're going to divide by that 8 both sides. You're going to end up with your x squared is equal to 25, square root both sides, and you get x is equal to 5. So you take that 5, and we're going to plug that back in over here from our y, and we're going to get y is equal to 10. Now remember, you have to make sure you're answering the question they actually asked. So if we go back to it, it says, what dimensions for the playbill would use the least paper? So it wants the entire playbill, not the printed area, it wants the entire playbill. So that means I have to take my 10 and my x is 5 and plug them in. So that's going to be 5 plus 4 is going to be 9. This was inches, so it's, or actually this was centimeters, so it's 9 centimeters. By, and then for the next one you have the y, the 10, plug it in, 10 plus 8 is going to give you 18, so by 18 centimeters. 9 centimeters by 18 centimeters are the dimensions of the playbill that are going to minimize the actual area there.